noise and noise, and there were several lines. This is page 21. And some of the lines refer to outdoors and some to indoors. Was that based on an attenuation, or were there actual measurements of indoor and outdoor locations?
That's a great question, and I will get you an answer. I don't know. That's from the Mashad and it's from the Health Canada and the Swedish Impact Study. There was the indoor values as well, but I don't know exactly how they did that. So I will look into that and find out.
That would be helpful so that the board can place this in their context. Another question, he opines that using the shutdown method is a preferable method for establishing background. Are you aware of any jurisdictions that use the shutdown method to develop a background and use that as a proxy? Say, we'll assume at location X, background is always going to be whatever is measured using one shutdown period. So that, say we're doing 5 different compliance testing over the life of a project. You don't have to do the shutdown every time.
Yeah, I can't point to a specific case, but I believe that is something that is done in Canada in some jurisdictions. That shutdown period that we're referring to, though, in that case, is usually over a longer term. So it's the project is in place, or maybe it's pre-construction, I'm not sure. But you're measuring background sound levels over a longer term at the exact locations that you'll be doing compliance monitoring. And then that would fix what that background sound level is. There are potential issues with that because these projects are installed for years, and background sound levels will change over time as the landscape potentially changes. But I believe that sort of methodology is used in some jurisdictions in Canada.
Tom, can I ask a follow-up question about one of my questions was about the shutdown method. Assuming the facility is already built, how long are these periods where you have to shut down the turbines?
Yeah, we've typically shut down for 20 minutes to a half hour. There is some lag time, so when you're looking at these graphs of when the operation is running, you're seeing if you have a low background sound level on high operational sound levels, you'll see the wind turbine sound level, and then the slow decline, and then clearly background, and then a slow incline until you get back up to full operation. But typically we recommend 20 to 30 minutes for shutdown period.
Just a clarification question with respect to, you had mentioned model uncertainty and accounting for that. And every time I see a reference to uncertainty, whether it's with the model or the manufacturer's rated sound power level, it always says, I'll just use 3 decibels in the example, it always says plus or minus 3 decibels. And when you account for that in the model, are you always adding 3 decibels to the output? So
yes.
In other words, so it will always, I'm probably using the wrong words here, when you account for uncertainty, you're always increasing the output of the model, you're never going to get a decrease.
That's correct, yeah. When we're entering in the uncertainty into a model, we're entering in the plus value of whatever the turbine manufacturer has said that uncertainty is. We don't typically enter in the uncertainty of the model itself. That's a separate uncertainty. And the reason for that is that we've done and we've conducted research, and we've also reviewed research that says what metrics provide the most accurate results in the model. And we are normally selecting the parameters like G equals 0.5 under certain conditions that are above essentially the best fit curve that's above all the data points. That's usually how we're doing it. So we're already selecting conservative parameters for the model. We don't need to take into account an additional model uncertainty.
Okay, thank you.
You were talking about in Maine that there's a fixed monitoring location in one of your 2 examples, and I was curious about that. Why do they have a fixed monitor? You said it's in concrete or something. It made it sound very permanent. And why did they do that?
Yeah, so this is before a lot of the current rulemaking in the state of Maine, or kind of in the midst of all the rulemaking that had happened. And so, the decision from the board was different from project to project. And on this project, they said, let's install permanent monitors so we can see what the sound levels are like in this thing. And they required it on this one project. So it's a permanent sound monitor in the middle of the forest. Trees had to be cut down in order to install it there so that we have an open yard. So it's not immediately next to trees, and also so that we get sunlight for the batteries, because the batteries are run off solar power. And it's not uncommon, but sometimes it does die in the middle of winter because we'll get snow build up on the solar, and it won't get enough power, and we'll have to go out there and fix it. But it's a concrete pad, a 10-meter high mast, and a permanent sound monitor. Expensive thing, but it was required for one project.
Does it have benefits in terms of the amount of data you're getting?
You know, I think if it was, I think if you had multiple continuous monitors, there would be more benefits, but that's one location. And so what we've seen is that it's essentially the same thing as us going out, setting up a long-term monitor for 2 weeks and analyzing that data, except that we have a year's worth of data to analyze.
And my last question is, you said other states don't look at aesthetics when it comes to sound. You did distinguish between aesthetics and annoyance. Do other states look at annoyance?
That's a good question. I'm not aware of any regulations that specifically look at annoyance. But oftentimes, and you'll figure this out with writing this rule, you don't put the reason that you set that level necessarily in the rule, right? And so some of the limits from state to state may be based on annoyance without explicitly stating that they're based on annoyance.
Thank you.
I had a clarifying question. Towards the beginning of your presentation, you made a recommendation that you should modify the pre-construction sound model based on the monitoring results. And there is some language in the proposed rule that would require that, and I wanted to understand whether your recommendation was simply that we retain that, or whether you had changes that you would recommend to that language.
I don't recall that language in the proposed rule, so if that's there, I suspect it's covering what my recommendation is. I remember it being recommended by other parties in earlier workshops, and I essentially wanted to second that recommendation from earlier workshops.
Okay, and if you are interested, you don't have to take a look at it now. You can address it in your final comments. It's 5.706C.
Great, thank you.
Proposed rule. Turning to the studies you talked about with the dose-response relationship for annoyance, I was interested how those studies account for, or what their setting is in terms of background sound, with the understanding that the dose-response relationship may vary in areas of high or low background sound.
Yeah, so the sound levels that are presented here are the sound levels attributable only to the wind turbine development itself. If background sound levels are higher or lower, that may affect annoyance, but most annoyance studies are assuming that there's a dominant source that's causing that annoyance. Specifically how these 3 sets of tests were done in terms of accounting for background sound levels, I can't speak to today, but I can certainly look that up and provide information on that.
And so, in that vein, I would be interested in knowing whether they are, say, in an environment where a typical background sound level may be in the high 20s, low 30s dBA, or maybe in the mid to upper 40s. You know, I could imagine that may have a significant impact on the degree to which people are annoyed. So it'd be interesting to understand that.
So that would be what's the background sound levels and the site-specific studies done for these sites. I do know the one study is Health Canada, which is a variety of sites across Canada, so the background sound levels are going to vary across the study. The curve is based off of all of those sites, right? But I can look into what is done for the Dutch and the Swedish sites and the Japanese study as well.
That would be helpful, thank you. That's all.
Questions, yes?
Eddie, could you go back to when you were talking about the NRO capabilities?
Yes.
of the turbines. You said there was only one turbine on the market that could do a 4 decibel swing, shall we say? Is that what you were saying?
I said there was one that
One.
I'm aware of that can do a 5 decibel
5,
swing. I think
okay.
there are more that can do 4,
Oh,
but
okay.
it's still not, you know, entirely common among all manufacturers.
Okay. Rev would be concerned that if the decibel swing was too loud, that projects would be limited. You would end up forcing a use of a turbine that may or may not be suitable for Vermont's environmental conditions, and also would likely be. Are these more expensive, the ones that have that larger capability? Do you know what the?
Yeah, that's
Maybe
kind of
I'll
outside
look
of my
into that.
area.
So just, we'll perhaps comment on that and keep into consideration that if there is only limited individual manufacturers or specific model types that can meet that level of swing, it may be fairly restrictive compared to a 2 or 3 decibel swing.
Yes. I want to correct my previous statement on NRO for those small turbines. What I meant is what he said, is they're not capable of adjusting pitch. I do believe they can shut down. And
So
their
stop,
dump
by
load.
shut down, you stop.
Yeah, I
spinning.
believe that they're small enough that their dump loads will bring them to a stop.
Okay.
Okay, so I just realized I was wrong.
I was inferring from something that was said earlier, that these smaller ones can actually keep spinning just from the wind,
Well,
the way old-fashioned
some of them are very, very old, and people don't even buy them anymore. So I'm not familiar with those. I know that the Berge, I believe, has the dump load will bring the blades to a halt. I think the Skystream will do the same. The only way that they will keep on turning is it's kind of like in, I think the Berge kind of folds sideways, so it might turn a little bit. But in general, I think it is possible that you can, there is a switch, which is manual, I believe. You'd have to put some sort of program on it. It'll take off the grid and put the dump load on and bring them to a stop. Okay, so, but they don't have the ability to change RPM.
I would ask the board to consider any of the information that I presented in terms, and in the light of large wind turbines, not small wind turbines. I haven't really taken that into account in any of this information.
Yes. Eddie, you showed 2 main sites. Can you identify those sites?
I may be able to. I will check, and if I can, I will submit that to the board. The one site I can say specifically, because it's in the public record, the site that has permanent monitoring at it is Spruce Mountain.
Okay. I just don't, I've got a number of questions. It's just so difficult that wind turbines have the tightest hold on data sites. It's amazing. I've worked with all kinds of noise sources in my 40 years, and I've never had such a tight hold on critical information. I've got a question. You treat daytime noise from a wind turbine the same as nighttime noise. Is there a difference atmospherically between daytime and nighttime?
Atmospherically, the sound level, atmospherically, it's not strictly a daytime, nighttime, right? Atmospheric conditions change all the time. So sometimes nighttime will be different, sometimes daytime will be different. I'm recognizing that the atmosphere is different from time of day.
Thermal layering, thermal inversion is a critical. This is why nighttime you hear that distant train, is because the cool air is on the ground, and during the daytime you don't hear that distant train because the cool air is aloft and the sound refracts up into the cooler air.
Yes, I understand how sound propagation works, and that based off our temperature inversion, it bends downward, and it can also bend upward. I would add that in answering your question, I am not confirming the assertion that we treat daytime different than nighttime. I'm not exactly sure how you're referring to that, but I'm not accepting that assertion.
Well, a wind turbine is a 24-hour noise source. Therefore, the critical time is the 35 dBA nighttime. It has to meet that criteria. And the other is, can you name a nighttime bird call that needs to be removed from the data?
I would offer that question is irrelevant, and I didn't.
You used it in your data.
That is false. I did not speak to nighttime bird calls. I spoke to bird calls in general being removed from the data, and specifically the definition from daytime and nighttime includes sunrise and sunset, and the time in which birds are most active in terms of bird call is sunrise and sunset.
Okay. Then ANSI allows for, American National Standards Institute, a proxy measurement. Yet you say, no, that's not good. ANSI approach is not relevant for wind turbines.
Just to clarify the question, by proxy measurement, you're saying that you have a distant monitor measuring background sound levels and a closer monitor measuring operational sound levels? Is that what you mean?
No, your noise source is operating, and you need to find a location where that noise source is not audible that's equivalent to it. That's called a proxy location.
Yes, that's what I was just wanting clarification as to what you meant. I did not say that it's not adequate for wind turbine acoustics. I did say that it's not adequate for the Northeast when you're dealing with heterogeneous landscapes and mountainous and hilly terrain. That method works very well in the Midwest when you have homogeneous landscapes, when you have crops and flat terrain, and you can go 2 miles down the road, similar traffic patterns, and you're getting similar background sound levels. But that does not work in the Northeast.
Okay, so you're talking about that. Then I'll end up asking, is the atmosphere homogeneous at night?
No.
Okay. Then you're open to all kinds of errors due to the atmospherics. And you were talking about your model. You've taken your model and you've compared it to your measurements. When I have done that, we would end up applying a model calibration or correction factor that was added on to measuring uncertainty and the prediction limitations of the model plus or minus 3 dB. So when you apply the two corrections for measurement uncertainty and modeling uncertainty out to 1,000 meters, and that's it. That's all it's good for. Where does your calibration correction get applied?
I'm not sure I understand the question.
Okay, I predict a sound level out to 500 feet, and it says I'm going to be measuring 48, or it predicts 48 dBA, and I go out and I measure 53. What do I do?
You get a model that accurately predicts the sound level.
Wait a minute. Models, I quoted the designer for Cadna, who said that plus a 3 dB is the best we can do. That's it. He says, we don't know the layer stratification on that. And that's out to 1,000 meters and a 30-meter height differential. This is where Vermont has failed. We have not applied a safety margin because Vermont is beyond the test parameters on flat ground, and we have distances that are greater than the model can predict accurately.
I would offer that I believe we do have a safety margin considered in the models. That is done through the selection of the parameters that we use in the model. We've looked at studies that look at a variety of distances out from wind farms based off of model data and monitor data. And the reason that those model parameters are set is that those are the most conservative assumptions to overpredict the actual measured levels from these projects. That is how we do our modeling. In the past, if we've done anything differently, it would be because those model parameters have been dictated to us by governing bodies that say you must use X modeling parameters.
So, who are you representing here today?
I'm representing RSG.
And so, you've been working with Renewable Energy Vermont through, for their presentation through Vera, and you've done the work on Georgia Mountain Wind and Lowell Kingdom Community Wind, and your firm is engaged in Swanton Wind and Holland Wind, right?
Sorry, what was the last one?
Holland Wind.
Holland.
Or I forget what it, Derriere Wind. Is that true?
Yeah, we have a number of clients, and the ones that you mentioned are our clients.
So you have an economic interest in assuring that this standard that you're recommending, that is the same that we've had, stays in place so that your company can do more work.
Yes, but I would say that if the rule goes through as planned, at least in terms of the limit, and there is no further wind development in Vermont, that the amount of wind work that we do in Vermont is such a minute part of our business. I'm here mostly because I'm interested in noise policy. That's why I did the master's degree that I did. I'm interested specifically in noise policy, and that it's done well because it propagates. Les can attest to this.
Okay, so
let me finish. Bad noise policy will propagate from one location to another, as will good policy, but it just propagates everywhere. And so my interest is that I think there are things in the proposed rule that could be fixed and better improved, which is why I'm here as RSG.
So now I want to ask about NRO mode as it was used at the Kingdom Community Wind Project, because as Chair Volz just asked, it could be adjusted, right? And that was said during the technical hearings on that project. But when the project actually went into place and the reports from RSG came in, it all showed that the half dozen turbines next to the Nelsons, who were terribly harmed by that project, their health was damaged. None of those were ever in NRO mode, and nothing was ever adjusted, and they complained repeatedly. And so when we hear that NRO mode can be adjusted, and it was promised it was going to be adjusted, but every report came in and it just said the same thing over and over again, it's hard to understand why NRO mode is being considered. So the other thing I wanted to ask you about is, you didn't mention the low-frequency noise component of this at all, and during those other wind projects, Ken Kaliski testified for RSG that infrasound was not a component of wind turbine noise. So what is your company's current position on low-frequency noise and infrasound as it relates to wind turbines?
By answering your question, you made a lot of assertions in there, statements, and by answering your question, I want to say that I'm not accepting a lot of those assertions. But I will answer the question about low-frequency sound and infrasound. We know from the Massachusetts Clean Energy Center study, which I think Howard may have presented a graphic earlier today from that study about infrasound. We know that wind turbines produce infrasound, and so we understand that. Our professional understanding, though, is that the infrasound that's produced by wind turbines is below audibility thresholds, and it also is significantly lower than so many other infrasound sources throughout the world and in communities currently today. And people are not complaining about infrasound at those levels from those other sources. Infrasound from wind turbines is significantly less than that.
And low-frequency noise?
It's all a spectrum. So do wind turbines produce low-frequency noise? Yes. Do we measure it? Yes. Do we model it? Yes.
Should it be a component of the rule?
It is a component of the rule. It's included in the sound propagation modeling that we do. We have to model low-frequency noise.
For compliance, should there be a limit on it?
If the board is interested in regulating low-frequency noise, then I would recommend that they pick levels by frequency bands, by octave bands, and regulate them based off of whatever the current scientific literature is on impacts at those frequency bands.
So you would support an LFN standard?
I don't think it's necessary, no.
Okay,
Right.
one last question. You're aware that there are currently and have been dockets at the board about Georgia Mountain wind and noise complaints. Is that right?
Yes.
Do you consider that a success of your company that this has happened, or what, we're kind of here because of RSG's testimony that's been accepted by the board in Lowell and Georgia Mountain. And so when we're trying to come up with something to improve on it, and you're recommending we stay with the same standards, how do you address that? Do you take any responsibility for the problems that's brought us here?
To be clear, I haven't recommended that we stay at the current standards. I've been very explicit about not saying what level we should be at. I think the board should pick levels that reflect the current state of scientific literature and the values of Vermont. I've stated that from day one when the board opened up workshops on this. So I'm not recommending that. I'm not making a recommendation on that front. I've simply made observations that to the extent that they're looking at aesthetics or health impacts, if those are the values that they're trying to protect, then these are the levels that they should consider, or maybe the levels they're considering are too high or too low. That's what I've done in this case. The question about the success of our firm, how I measure success, I think is irrelevant to this. I'm not going to speak specifically to those dockets. I'm here to talk about the current standard for wind turbine acoustics.
I have one follow-up. I'm going to bring in one of my last slides was the Danish has a low-frequency noise standard. And since low frequency was talked here, Danish has the standards summing the 10 hertz to 160 hertz, 1/3 octaves, A-weighted. So you get the penalty of audibility of the ear, and that number is 20. So if you want to comply with the Danish low-frequency noise standard, which is I recommend, the value is 20 on the
Interior?
for the low frequency.
For
Yes.
indoors?
Yep. I won't go indoors. I mean, I think it might be an outdoor standard. I'm not sure, but those low frequencies will penetrate and enter a house very easily. And when you see the variability of inside to outside, it depends on the area of the window and the acoustic signature that's outside. If you have more high frequencies outside with an open window, you have more attenuation coming through the window than if you have rich and low frequencies. So when you see the variations 26 to 10 or 10 to 26, frequency content of that makes a big difference. And I ended up doing the conservative approach where EPA says transportation at a distance, low frequency, about 5 dB entering a room. That's because the sound waves come in through the open window. Now sound travels three-dimensionally, but it comes in through the open window and it has to fill that room. Well, now it has the ability to reflect off the walls, and now it's three-dimensional again, and there's a 6 dB reduction because there are 3 axes present. So I think having low frequency content is good. I still recommend your 35. You're right on the money.
If I could just mention the Danish, they did impose that limit. It's still in place. They also studied it after it was in place, and they found that the audible sound limit, the dBA limit, was actually the controlling factor, and that low frequency noises stayed well below the low frequency limit, just being governed by the audible limit.
Okay, we need to keep moving. Okay, should we go to the department next?